In this session, I'm going to introduce the k-medians and the k-modes clustering methods as two interesting alternatives to the k-means clustering method. Why we want to do k-medians? Because the medians are better than means when we encounter outliers. Medians usually less sensitive to outliers comparing to means. For example, in a large firm, there could be many employees. When you want to find a median salary, even when you add a few top executives, the mean salary may change quite a lot. The median could still be very stable. So that's the reason instead of computing the mean value of the object in a cluster, so we take medians as the centroid, and we use L1 norm. That means the Manhattan distance as our distance measure. The criterion function for the k-median algorithm is written as this. Essentially, the total sum should be k from 1 to the number of cluster k. And for each cluster, the object in the cluster, you just look at the difference, take their absolute value of their distance to the median. The k-medians clustering algorithm essentially is written as follows. The first, at the very beginning, we select the k points as the initial representative objects. That means as the initial k-medians. Then we get into this loop. We assign every point to its nearest median. Then we recompute the median using the median of each individual feature. Then this process repeats until the convergence criterion is satisfied. Then we look at k-modes as another interesting alternative to k-means. K-modes essentially is to handle categorical data, because k-means cannot handle non-numerical categorical data. Of course, we can map categorical value to 1 or 0. However, this mapping cannot generate quality clusters for high-dimensional data. Then people propose k-modes method, which is an extension to k-means by replacing the means of the cluster with modes. The dissimilarity measure between object X and the center of a cluster Z is written as follows. This is the dissimilarity, or we can say distance measure, distance function. For the J field of object X, that means X sub J, and look at the J field of the cluster center Z. What's the distance? Essentially is if this object is not equal to the center on the same attribute, essentially say they are different, then we just say the distance is 1 because it's very dissimilar, or the distance is the largest. However, when this value is equal to this attribute center here, then we give this formula. This formula actually means if there are many objects occur the same in this cluster, then this value actually will be very small. For example, if the attribute cluster, there's only one value, but it's very frequent, and this guy actually equal to this value, then this division will lead to 1, and the distance is the smallest. In most cases, is the more frequent for this J value, and this one will be closer to 1, so the distance is smaller. And if this one is very rare, you're equal to the very rare value, and the number of distinct values is quite big, so your distance is closer to 1. So this is quite reasonable definition. That means this dissimilarity measure or distance function essentially is frequency based. The more frequent the closer, the less frequent a little far away, even you're equal to this value. The whole algorithm we will not list here, but it's still based on the iterative one. We first do object cluster assignment, then doing centroid update, Then we take this one to loop until the criterion reached. Okay. Then there's another alternative method called fuzzy K-Modes method. The fuzzy K-Modes method essentially is calculate the fuzzy cluster membership value for each object to its cluster. Simply says, you give a fuzzy cluster value. Okay, if it's very close to this cluster, the fuzzy value is closer to 1. Okay, it's far away from this cluster, and the fuzzy value is somewhat closer to 0. Okay. And if we have the data, some attributes are categorical attributes, some attributes are numerical attributes, we can use a K-prototype method. Essentially, for numerical one, we can use a method, the function similar to the K-means. And the categorical one, we can use similar to K-modes. And finally, we integrate this, we can get a K-prototype method.